Question 3 says, given that ax squared minus bx plus c equal to 0, full stop, find the values of x by completing the squares method, right? We saw something like this when we were generating the quadratic formula by the method of completing the squares. The only difference with this one is just that the equation of x is negative b, right? So we are simply going to repeat those same procedures, right? Okay, so the first step, we are going to start by sending the constant term c to the right hand side. So this will be equal to, it becomes negative c, right? The next step, we are going to make the coefficient of x squared to be unity, to be 1 now, by dividing all through by a, the coefficient of x squared. So we divide both sides by a minus bx divided by a is equal to negative c divided by a, right? So you will see a will cancel a. You will be left with x squared minus b over a. We can write this as b over a times x now. It's still the same as this, right? It's equal to negative c on a, right? Now the next step, we are going to add half the coefficient of x, all that squared, at the left hand side and at the right hand side, so as to obtain a perfect square, right? What is the coefficient of x? The coefficient of x is negative b over a. You take note of the negative side, right? So negative b over a half of it gives us negative b all over 2a, right? We are going to square both sides like this, squared, this squared, right? So this is what we are going to add at the left hand side and at the right hand side. And this will give us, let's continue here, this will give us x squared minus b over ax, right? Plus, we are going to add this now, negative b over 2a, all that squared is equal to negative c over a plus negative b on 2a, all this square, like this, right? We know this is a perfect square, right? And the factorization of this perfect square is simply x, because we take x here, plus what we have here in this bracket, all that square, plus negative b on 2a, all this square. If we expand this, we'll go back to this, right? Is equal to negative c on a plus, we are going to expand this, right? Negative b squared, negative b times negative b gives us positive b squared, all over 2a squared. 2 squared gives us 4a squared, like this. That's good, right? Here we know positive, negative. Who stays?
Negative.
This will give us x minus b on 2a, all this squared is equal to, here we are going to send in the negative side, right? It is like, for example, when putting on your dress, you always send in the wrong side now, right? And the good side of your dress will be out. So most often in mathematics, we always send in the negative sign to hide it, right? So this will give us b squared on 4a squared minus c on a, like this, right? And this will give us x minus b on 2a, all this squared, to be equal to, we need the LCM of the denominators of these two fractions at the right hand side, right? What is the LCM of 4a squared and a? The LCM, we consider this now, 4a, wrong, 4a squared 4a squared. 4a squared divided by 4a squared. 1 times b squared. B squared. You bring down the operation sign, which is minus, right? 4a squared divided by a. 4a times c. 4ac. Like this, right? The next step, we are going to take square roots on both sides. We take the square root of x minus b on 2a, all this squared is equal to the square root of b squared minus 4ac on 4a squared. Okay, remember, when we treated the indices, sets, and logarithm, right? I mentioned something like this. If you have the square root of a fraction like this, a over b, it is simply equal to the square root of a over the square root of b, right? Next, if you have the square root of, for example, let's say we have x squared like this, it is simply equal to plus or minus x like this. You saw this now. So we are going to apply it here. This will simply give us, let's continue. So this and this will go. We'll be left with x minus b on 2a equal to, we are going to put the plus or minus sign now. Plus or minus, we break this fraction, right? The square root of b squared minus 4ac all over, we are going to break this, right, as the square root of 4a squared, right? And this will give us x minus b on 2a is equal to plus or minus the square root of b squared minus 4ac like this all over. The square root of 4a squared gives us 2a. That's good. Like this. The next step, we need to make x the subject of formula by transferring negative b over 2a to the right hand side now. This will give us x will be equal to, it becomes positive now, b on 2a plus or minus the square root of b squared minus 4ac on 2a. You will see these two fractions, they have a common denominator, which is 2a, right? So we can add or subtract the numerators, then we maintain the common denominator. This will give us x equal to b plus or minus the square root of b squared minus 4ac on 2a, right? We cannot be working with plus and minus at the same time. And we know a quadratic equation has two solutions now. So now we can write down the two solutions, right? Therefore, right? Look here. Therefore, x will be equal to the first solution, b plus the square root of b squared minus 4ac all over 2a. So this is the first solution for x is equal to b minus, right, the square root of b squared minus 4ac on 2a. So these are the two solutions of the quadratic equation ax squared minus bx plus c equal to 0. Right? Okay. See, look up. This solution, you will see that this, there's a difference here. This is the quadratic formula, but there's a difference. There's no negative sign here.
Yes, sir.
The reason why there's no negative sign in front of b is because here b is negative. Right? So that's all. And we are done with that solution. Very easy. We end